Welcome to my YouTube channel. Today we are going to discuss about the explain the classification of electrical network. Introduction to electrical networks. In electrical networks are collection of interconnected electrical components. They are essential for distribution and control of electrical energy. Understanding their classification helps in designing and analyzing various systems. Definition of for the electrical networks. Electrical networks consist of resistor, capacitor, inductor, and sources. These components are connected through conductive paths to perform a function. The behavior of these networks can be analyzed using circuit theory. Types of electrical network. Electrical networks can be broadly classified into two types, linear and non-linear. In linear network follow the principle of superposition and exhibit uniform behavior. In non-linear networks do not adhere to this principle and can exhibit complete behavior. Complex behavior. Linear electrical networks. In the linear networks contains components those current voltage relationships are linear. These networks can be analyzed using various techniques like superposition. Circuit elements like resistor and capacitor typically create linear networks. Nonlinear electrical networks. Nonlinear networks involve components like with nonlinear current voltage characteristics. Diodes and transistors are common example of nonlinear elements. Analysis of these networks often requires specialized techniques and simulation. Passive and active networks. Electrical networks can be classified as passive or active based on these components. Passive networks do not require an external power source for operation. Active networks include components that can supply energy such as amplifier. Passive electrical networks. Passive network consists of resistor, capacitor and inductor. They cannot produce energy and can only store or dissipate it. These networks are commonly used in filters and signal processing. Active electrical networks. Active electrical networks contain components that can amplify or generate power. They are essential in applications like signal amplification and oscillators. Active networks can influence the behavior of passive components within them. AC and DC networks. Electrical networks can be classified based on their operating condition as AC or DC. AC networks use an alternating current, while DC networks using direct current. The analysis techniques differ significantly between these two types of networks. AC electrical networks. AC networks are characterized by these use of sinusoidal and non-sinusoidal waveforms. They often involve reactive components like inductors and capacitors. Power calculation in AC networks must consider phase differences. DC electrical networks. DC electrical operate with a constant voltage or current over time. They are simpler to analyze as they do not involve phase angles. Common amplification include battery powered devices and power supplies. Circuit and series and parallel networks. Networks can also be classified based on the configuration of these components. Series networks have components connection end to end sharing the same current. Parallel network having component connection across the same voltage source. Series electrical networks. In series networks, the total resistance in the sum of individual resistance. The voltage divides among the components based on these resistance values. Failure of one component in a series network typically results in complete circuit fail failures. Parallel electrical network. In parallel electrical networks, the total resistance is calculated using the Repeater formula. Each component receives the same voltage, allowing for independent operation. If one component fails in the parallel network, the remaining component continue to function. Nodal and mesh analysis. Electrical networks can be analyzed using nodal or mesh analysis techniques. Nodal analysis focuses on the voltage at each node in the circuit. Mesh analysis involves the calculation of current in independent loops. Frequency response of network. The frequency response characterized how network react to different frequencies. These classifications helps in understanding the filtering and amplification properties. It is critical for designing circuits in communication and signal processing. Impedance and admittance networks. Impedance network consists the total operation to current flow in AC circuit. Admittance networks focus on the ease with each current can flow. Both parameters are essential for analyze AC circuit behavior. Applications of electrical networks. Different classification of electrical networks find application in various fields. They are used in telecommunications, automotive, and consumer electronics. Understanding this classification aids is effective design and troubleshooting. Summary of classification is electrical networks can classify based on their component functions and configuration. The main categories include linear versus non-linear, possessive vs active, and series vs parallel. Each classification has unique characteristics that influence analysis and design. Conclusion of this topic. A comprehensive understanding of electrical network classification is virtue for engineering. Knowledge of different types of enhances the ability to design effective circuits. As technology evolves, new classification may emerge, requiring connecting continuous learning.